Hello, Algebra and Honors Algebra students. Mr. Lawrence here, and here's another probability video. And in this video, we are going to define probability and odds. And I notice I have a singular version of odds. It should be plural there. Sorry about that. And we're going to define them this way. Probability is going to be defined as successes over total outcomes. Okay, so think about it this way. What's the probability of rolling a 2 on a 6-sided die? Let's pretend you're playing a game, okay? And if you roll a 2, you win. Well, how many 2s are on a 6-sided die? There's 1. So your success probability of rolling a 2 would be 1, because there's 1, 2 on the 6-sided die. And how many total outcomes are there? Well, there's 1, 2, 3, 4, 5, 6. So your probability of getting it is 1 out of 6. Probability of flipping ahead is 1 out of 2. Okay? Now, odds are very similar to probability, except they're defined as the success over the failures. Success over failures. So, if you're playing my game, the probability of rolling a 2 on a 6-sided die, how many ways are there to win? Well, there's 1. How many ways are there to lose? There's 5. So your odds are actually 1 out of 5. Now I got to tell you, the lottery likes to lie to you, because what the lottery does, you notice 1/5, 1 out of 5 looks like a better chance than 1 out of 6. On lottery games, they never print the probability of winning. They always print the odds of winning, because it looks like a bigger fraction. This looks like 20%. In reality, it's 1 out of 6, because total outcomes would be 6. This one would only be 16 2/3%. Okay? So, just a little bit of clever marketing there. Tell you what, let's see if we could figure out the probability of, let's see, rolling, let's go on a 20-sided die, rolling a prime number on a 20-sided die. Okay? Well, let's count the prime numbers. 1 is not prime. Prime number is a number that only has 2 factors, 1 and itself. 1 only has 1 factor, so it's not prime. Okay, so 2 is the only even prime number. 3 is prime. 4 is not. 5 is prime. 6 is not. 7 is prime. 8 is not. 9 isn't, because 3 times 3 is 9. 10 is not. 11 is. 12 no. 13, 14, 15, 16, 17 is. 18, 19, and 20, of course, isn't. So let's see, how many primes do I have here? 1, 2, 3, 4, 5, 6, 7, 8. So the probability would be equal to 8 over 20. Simplify that, we better said as 2 out of 5. The probability would be 2 out of 5. Okay? By the way, what would the odds be? Well, the odds of doing that same event, okay, that would be 2 out of 3. Yeah, because you'd win 2 of the 3 times, or 2 times you could win, and 3 ways you could lose, because the total outcomes is 5. 5 minus 2 is 3. Okay, that's where the 3 is coming from. Total number minus. Okay, now some of you probably think, well, wait a minute, weren't there 20 possible? Okay, let's do it with 20. All right, there are 8 ways to win. There will be 12 ways to lose. Let's divide. Wait, do I have a mistake here? Oh, yeah, there is a mistake here. Sorry. There's 8 ways to win, so there's 12 ways to lose. There we go. If I divide both the numerator and the denominator by 4, look at that, I get 2/3. I prefer to do probability, simplify it, and then just do the odds from there. It's a little bit easier. Anyway, what would the probability of flipping a coin and getting a heads? Well, there's one way to get ahead, and there's 2 possible outcomes. So it'd be 1/2. What would the odds be? Well, the odds would be 1 to 1, right? Now, just to see if you could figure this out, let's say we're going to roll the die and flip the coin. What's the probability of rolling prime number? Again, we're on a 20-sided die, and flipping a heads. What's the probability? Well, if you know the probability of rolling the prime was 2 out of 5, and the probability of flipping a head is 1 out of 2, well, then you can multiply your two probabilities together, and that will get you the probability of both events happening. What did I just use there? The fundamental counting principle. By the way, I love to divide first, simplify first. So 1 times 1 is 1, and 5 times 1 is 5. And so the probability of doing both those events at the same time, both happening at the same time, would be 1 out of 5. Okay, the odds would be 1 out of 4. That's pretty simple. All right, let's talk about some jelly beans. Maybe the Easter Bunny was really good to you and brought you some yummy jelly beans. And in a bag, quick, get me a bag. In that bag, there are 3 red jelly beans. Dun, 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 dun. There are 5 blue jelly beans. No, just you wait. Those of you who are on my bus in DC, we're going to be eating some jelly beans. And 4 green jelly beans, right? Okay. So, I want to know, first of all, the probability of reaching in and getting a red, probability of reaching in and getting a blue, and then the probability of reaching in and getting a green. Let's figure out all those really quick. Well, the probability of getting a red would be 3 out of how many total? Well, let's see, that's 9. Looks like out of 12, so a better answer would be 1 out of 4. Probability of getting a blue. Well, that would be 5 out of 12, and that doesn't simplify. Probability of getting a green, looks like there's 4 greens in there. 4 out of 12, looks like we're going to get 1 out of 3, 1/3. Okay, now, what's the probability? And we're going to do 2 types. We're going to do with replacement and without replacement. By the way, if I wanted to do odds, I would just do like 1 out of 3. For the blue one, I would do 5 out of 7. For this one, I would do 1/2. Okay, but what's the probability? And we're going to put these jelly beans back. Okay, we're going to do it with replacement. We're going to reach in, we're going to get a red, and then we're going to get a red, and then we want to get a green one. Okay, and this is with replacement, meaning, okay, we're assuming we're not cheating. With replacement, we're going to reach into this bag, we're going to see if we can get a red jelly bean. If we get red, and then our second draw we get red, and then our third draw we get green, we win the game. Okay? So probability of red is 1/4. We put the jelly bean back, so the probability of red is still 1/4, and the probability of getting a green is 1 out of 3. Okay? Now this is the only way to win this particular game. Fundamental counting principle says I'm going to multiply. 1 times 1 times 1 is 1. 16 times is 48. 16 times 3 is 48. So 1 out of 48. What that means is, if you played this game 48 times, you should only expect to win once out of 48. Okay? Now, what would the probability be of the same problem without replacement? So again, we're going to go red, red, and green. That's without replacement, meaning you're going to eat the jelly bean. You're not putting it back in. So you pull out a red one, and then you eat it. And then you try to draw another red one. Okay, well, the probability of getting the first red is still 1 out of 4. Now the problem is the second red. There's 1 less red jelly bean in there. Why? Because you ate it, silly goose. So now there's only 2 red jelly beans in the bag. Okay? So the probability is going to be 2 over 11, I believe, right? Because now there's only 11 total jelly beans in there. And then for the green one, well, there's another red jelly bean gone. Joop. Okay. And so the probability of getting a green jelly bean out, well, there's 4 greens, and there are 10 jelly beans left. Fundamental counting principle says I should multiply. And so here's what I'm going to do. I'm going to cancel these 4s. I'm going to do 2 into 10 5 times. And I'm going to multiply 1 times 1 times 1. And 1 times 11 times 5, 55. So the probability of that happening is 1 out of 55. If I played 55 times, I should only expect to win once. Now the odds of doing it would be 1 out of 54. The denominator is always the probability denominator minus the numerator. Okay, 1 out of 54. Okay, that's going to be the video. Hopefully we'll get some practice. If you want to come in, lunch, or after school, please do so. Mr. Lord signing off. Have a good night, everybody.